Welcome to the debate. Today we are tackling really one of the most significant industrial transformations of our age, the automation of load and haul operations in the global mining sector.
And it's a transformation, as you say, that carries enormous consequences. I mean, far beyond just the bottom line. Wouldn't you agree?
Absolutely. We are focusing specifically on the primary logistical heart of surface mining, the movement of excavated ore from the dig face to the processing plant, the load and haul cycle. And the scale of automation here, well, it's reached critical mass. We've seen Komatsu's fleets of over 750 autonomous haul trucks move more than 10 billion tons of material. That's a staggering number. And it's matched almost ton for ton by Caterpillar's MineStar systems, accounting for, an additional 8.6 billion tons hauled autonomously. The efficiency and safety figures coming out of these fleets are profoundly compelling.
That scale is certainly undeniable, yes. And those numbers reflect significant technological achievement, no doubt. But they also force us to ask a crucial question, I think, about the real costs and, maybe more importantly, who ultimately bears the burden of this transition.
Precisely. So our central question today is this. Does the massive productivity and safety leap provided by these automated systems justify the, let's face it, enormous capital intensity required for implementation, or whether, as you suggest, it perhaps conceals severe hidden costs related to structural equity across the industry and workforce disruption in surrounding communities? Now, I'll be arguing that this move toward automation is actually a strategic, necessary leap forward, focusing primarily on those undeniable gains in efficiency, predictability, and, of course, safety.
Okay, well, I come at it from a fundamentally different perspective. While the operational benefits are clear for the global majors, the companies that can actually afford the initial outlay, I'll argue this is a risky bet. A bet whose hidden costs, particularly related to financial accessibility, workforce stability, and crucially, systemic operational resilience, have not been adequately addressed. For me, this isn't just a cost analysis. It's really a structural analysis of the industry's future shape.
All right. Let me start then by establishing the operational foundation of my position. I see why you prioritize the external costs, I do, but the internal benefits they're too immense to ignore. Automation, fundamentally, is about creating safer, smarter, and ultimately greener mines. The core argument rests squarely on productivity gains. Look, autonomous fleets achieve near-perfect operational consistency. They run 24/7 with zero shift change delays, zero fatigue issues, and significantly reduced unscheduled downtime. This isn't just marginal improvement, it's a structural necessity now for meeting modern metal demand. We're seeing, in some cases, up to 15% more ore moved per hour compared to even the best manned fleets.
15% is significant.
It is. And furthermore, the primary benefit is the unequivocal safety improvement achieved by removing human operators entirely from inherently hazardous, high-traffic working zones. This leads to a demonstrable reduction in major accidents. It just does. Beyond safety and tonnage, cost control is enhanced. Lower long-term labor costs combined with highly optimized maintenance cycles supported by predictive AI, which means you shift from reactive to proactive fleet health management. And finally, these tight operational parameters align perfectly with ESG goals, promoting less erratic movement, less fuel burn, and facilitating far tighter environmental monitoring. So the benefits stack up internally.
Okay, that's a compelling argument if you focus purely on internal metrics and operational perfection. But that perfection, I argue, comes with a steep price for industry equity. My position is that these immense benefits overwhelmingly serve the Tier 1 miners, the globally diversified companies with massive capitalization, while creating substantial and I'd say dangerous structural risks for the broader industry and the communities that rely on mining employment. That high upfront capital intensity is prohibitive. It's not just the trucks themselves. It's the network infrastructure, the centralized control centers, the sensor arrays, the specialized training. It's a huge package. This is a critical barrier to entry that effectively shuts out mid-tier and regional operators. And honestly, I just don't buy that the operational benefits outweigh the severe social costs of workforce disruption, specifically the hollowing out of high-paying haul truck jobs. We also face real, potentially existential systemic risks. Technology dependence brings severe cybersecurity threats and tangible downtime risk if these complex interconnected systems fail. This is already resulting in an unequal industry impact, creating a clear two-speed industry where only the majors can really afford the innovation ticket.
Let's delve into that social cost immediately, because I think the narrative of destruction is perhaps misplaced. We need to frame this as job evolution and skill upgrading, rather than just pure displacement. You highlight the risk of hollowing out mining towns, and I understand that concern, the immediate vacuum created by job loss.
We absolutely must address that immediate social cost. I mean, when you automate hundreds of truck positions in a remote mining town, you are potentially pulling out the economic backbone of that community. The promise of new, better jobs often rings hollow because the transition support or the infrastructure for sophisticated technical retraining simply doesn't exist locally in many cases. Mining communities are often geographically isolated, right? They lack the educational pipeline to instantly pivot a seasoned truck driver into, say, a remote operations center technician. This lag, this gap, can lead to years of economic disruption and hardship while people wait for those sophisticated new roles to maybe, possibly, materialize somewhere else, often hundreds of miles away in a city-based control hub.
I'm not convinced that focusing solely on the lag justifies avoiding what is fundamentally a necessary shift. This evolution is happening because the industry must become safer and more efficient. It has to. The new roles created are not peripheral. They are central to the new operational model and are often higher paying and, importantly, safer. Automation isn't just job destruction, it's a demanding job evolution. We are seeing a shift in demand away from primarily manual skill and toward cognitive skill. The new workforce includes roles like LiDAR calibration specialists, fleet performance analysts using AI tools, and crucial ROC control staff who manage multiple fleets simultaneously from a safe distance. We're talking about technicians specializing in condition-based monitoring, shifting the workforce from general mechanics, perhaps, to data scientists managing vibration analytics to predict component failure before it happens. The net result, I believe, is a workforce that is inherently better protected and potentially better compensated over the long term. Avoiding this technological leap out of fear of transition lag simply risks ensuring the entire industry becomes globally uncompetitive.
But the accessibility barrier is precisely what threatens that overall industry resilience you mentioned. Let's turn back to capital intensity for a moment, because this is where the disparity becomes institutionalized. This technology requires, as we've said, billions in infrastructure. How can the industry justify embracing a technological model that inherently creates a competitive landscape only accessible to the largest, deepest-pocketed companies? This massive upfront investment inherently drives that unequal impact we talked about. If only Tier 1 miners can realistically absorb the billions required for full, safe deployment, the mid-tier operators stagnate. And this inevitably leads to market consolidation, a concentration of supply in fewer hands, which structurally, I think, reduces the overall resilience of the sector to shocks. Don't you see that risk?
That's a crucial point, though I would frame it, well, differently. This isn't really about active exclusion. It's more about defining the new baseline for strategic necessity. Automation is, frankly, no longer a luxury. It is rapidly becoming table stakes for any miner intending to stay globally competitive. Why? Because the pressure to reduce operational costs and enhance safety is now compounded by increasingly stringent ESG demands from investors and regulators. For instance, these autonomous systems provide the data fidelity necessary to prove carbon intensity reductions, something manual fleets simply cannot offer with the same precision. Operators who fail to adopt this technology risk becoming obsolete, not because they are arbitrarily excluded, but because they simply cannot compete effectively on efficiency, safety, and environmental reporting, which is now essentially mandated by global capital markets.
The reality is that these adoption gaps, the ability to meet this capital hurdle,
will decisively define competitive tiers in the 2025-2030 timeframe. Those who adapt early will likely reap the rewards. Those who don't, well, they face managed decline, perhaps.
Okay, even if we accept that premise of competitive necessity, we absolutely must scrutinize the new risks introduced by that very necessity. You speak often of the undeniable safety gain.
And I must reiterate that primary, undeniable safety gain. The unequivocal benefit of removing human operators from inherently dangerous working environments. That reduction in accident rates for human personnel alone is an enormous ethical and operational benefit that, frankly, must be weighted heavily against any cost.
I acknowledge the safety gains for individual human operators, yes, but the risk profile simply shifts, doesn't it? It shifts in magnitude and complexity. We seem to be exchanging localized operator risk for potentially massive systemic risk. The danger, as I see it, lies in creating an over-reliance on algorithms and this deep technology dependence. So yes, we fix the immediate risk by getting drivers out of the cabs, but are we trading it for a massive, potentially catastrophic failure risk at the network level? What happens when these complex, interconnected automated systems fail? The consequences are no longer just one truck going down, an entire operation could halt. The operational costs in terms of massive downtime and the consequential loss of revenue could be severe and far-reaching. That's a different kind of vulnerability.
That risk is absolutely recognized, you're right. And it is being actively mitigated through comprehensive, yes, expensive, redundancy architecture that is designed into these fleet systems from the ground up. We are talking about state-of-the-art resilience, not just better technology, but safer technology, designed with failure in mind. The architecture typically includes things like 3 layers of communication redundancy, fiber, wireless, and satellite backups to prevent single-point network failure. Furthermore, cybersecurity isn't just an afterthought. Operational networks are rigorously segregated from corporate IT systems specifically to ensure that a breach on the corporate side cannot paralyze the whole fleet. These systems are designed with layered fail-safes and specific protocols that allow individual trucks to execute safe stop procedures even with minimal connectivity. The solution to technology risk is robust, specialized mitigation, not avoidance of the technology itself.
But don't you see that specific, robust mitigation you describe is exactly what reinforces the inequity barrier? That advanced architecture, the triple redundancy, the segregated network protocols, the specialized cybersecurity personnel needed to manage it all, that is exorbitantly expensive, and it requires specialized expertise that is simply not uniformly available across the entire global mining landscape. When a major Tier 1 player implements that, yes, they achieve a certain level of resilience. But when a struggling mid-tier perhaps tries to implement automation on the cheap without that full investment, they expose themselves disproportionately to systemic failure and cybersecurity threats, feeding right back into the unequal impact problem. It feels like we are replacing a known, generally manageable risk, like human error, with an unknown, potentially cascading risk, like algorithmic failure or cyber intrusion, that is extremely costly to properly insure against or mitigate for everyone except the very largest players.
Well, it is arguably the responsibility of the operators to invest properly if they choose to adopt the technology. But the systems themselves also offer superior predictive maintenance capabilities, driven by constant data streams, which can offset some of that specialized cost by maximizing uptime and component life. The data derived from the operation itself is key to maintaining that resilience affordably over time.
Data only helps if you have the specialist staff readily available who can interpret the, say, vibration analytics and act on those predictive maintenance warnings immediately, right? That capability isn't universal.
Okay, to summarize my perspective then, automation in load and haul operations is, I believe, no longer optional. It's essential for achieving competitive advantage and meeting the mandated efficiency, productivity, and safety standards expected globally. The empirical evidence from billions of tons already hauled by the majors demonstrates that the productivity gains and unparalleled safety improvements outweigh the substantial capital requirement. It positions the industry for a smarter, greener, and ultimately more sustainable future.
The necessary transition costs are, in my view, simply the cost of modernization in this sector.
And my core position remains that while progress is undeniable, the industry must aggressively manage system security, resilience, and especially equity to truly balance this progress. Without robust plans to address technology dependence with high-cost mitigation strategies available more broadly, and without aggressively addressing the acute workforce disruption in a comprehensive manner, including providing real, local retraining infrastructure, not just promises, the industry risks substantial long-term backlash. Backlash from communities, from governments, and critically, from investors increasingly concerned about the long-term social license to operate.
Ultimately, the tension is clear. The debate, as you alluded to earlier, is probably no longer if automation happens. That seems to have been settled by the billions of tons hauled already.
Indeed, the focus must shift decisively, I think, to how companies manage the related costs, the people affected, and the significant systemic risks introduced. Navigating these adoption gaps and managing the associated trade-offs between safety gains and equitable access will undoubtedly define which competitive tiers survive and thrive in the period leading up to 2030. There are still many questions to grapple with here,